plastics as well. And the third one is carbon efficiency. Carbon efficiency in plastics and carbon efficiency in its alternatives. We're trying to sort of solve the problem in all three areas. So, interestingly, you would see a lot of the movement towards agricultural products, right? And like rightly said, one is that, if we were to step back, we'd see that a quarter of emissions currently globally come from agriculture, right? And this is not just it. To make these agricultural product plastics, they primarily rely on cash crops and cash crops that come from corn, soy, and sugarcane. And the environmental impact of these crops is extremely high on the environment. Corn and soy, historically has led to forest clearances, wildfires all over the world. It is notorious for topsoil erosion, desertification. It's a very, very long list, right? Apart from that, some of these polymers are modified to such an extent that they can live on for hundreds of years. Specifically, PLA, if it's not sent to an industrial composting system, can live for 100 years. Now, our solution, something has happened. Okay. Right. My slide is not loading very well. Just give me a moment.
In fact, I'm sure that this food for plastic is a very knee-jerk reaction, and you don't have enough food already. So, how are you going to start making? Already, there's a big debate about food
Absolutely.
versus non-food, even when it's going in for ethanol. So, how are you going to make all your plastics out of food? It's impossible.
Yeah, so there's a number which I talk about is that if we were to make bioplastics from food, it would require 7% of arable land in the world.
No,
So
and probably
when
we are
we're talking
reducing,
about food,
and probably we are reducing 7% arable land every year, where agri land is
any
going
which
to
way.
other use.
Yeah, yeah,
So you
absolutely
can't
right.
really afford it.
Correct, correct. Um, just a second. Yes. So, in terms of what we are looking to propose is that we look for solutions not in the 25% of the world where land is. We're trying to use 75% of the resources that go highly underutilized, and that's the ocean. One out of two breaths that we take comes from the ocean, right? 50% of oxygen, more than 50% of oxygen comes from marine life. In fact, it was even as higher as 70 to 80% a few hundred years ago. It's actually because of the oceans that are dying inside that the oxygen level has reduced. Apart from that, in the ocean, there is a seaweed species that grows. There is an algae species that grows within the ocean that's called seaweed. Now, algae is of two kinds. One is microalgae, and the other one is macroalgae. Macroalgae, which is more colloquially also known as seaweed. Now, seaweed requires no arable land. It requires no drop of fresh water. Does not require fertilizers or pesticides. It grows in less than 30 days, 30 to 45 days at best, depending on the conditions, which is faster than any cultivation that would happen for any cash crop also. Apart from that, the rate at which it grows is phenomenal. Some seaweed species can grow up to 2 feet a day, 2 feet a day. And because it's growing fast, the photosynthesis is fast. And because photosynthesis is fast, carbon absorption is faster than anything that grows on land. So that's how fast it grows. Apart from that, it also cleans up the ocean. So it's removing the acidity by removing carbon dioxide. It's removing nitrogen and phosphorus. Now, why nitrogen and phosphorus is in the ocean is because of the agricultural runoff, which is all the fertilizer runoff goes into the ocean, and nitrogen and phosphorus make the ocean nutrient rich, which is actually detrimental for marine life. So, a lot of marine life dies because of all the agricultural output that goes in. So when it grows, it removes the nitrogen and phosphorus as well. Now, with this material, which is the seaweed, we've created a product which looks a lot like plastic. It has certain hydrophobic properties. It is stretchable. It's very printable, so you can pick up any kind of color, multicolor. Right now, you're seeing black and gray. Probably for aesthetic reasons, it's been picked. But you can pick any print, brand print, and it picks it up beautifully. So it has no issues like that. It's biodigestible. So the formulations that we make, we keep in mind that if any ocean life or marine life or any person or animal on land were to consume it, they're going to be safe. So humans, it's safe for humans, it's safe for cows, it's safe for whales, it's safe for just about everybody. And it's highly compostable, I mean hyper compostable. So home compostability criteria requires you to break down in a certain amount in 90 days and completely go away in 6 months. Our materials will break down in a matter of 4 to 6 weeks itself. So it goes away very, very quickly, and it is backyard compostable. And if it enters the ocean, depending on the temperature of the water, so if it goes into, let's say, Indian oceans or Indian temperature rivers and waters, barring Himalayan just sort of melted water, the average conditions of the water, it will go away in a few hours. And if it was boiling hot, of course, it will go away very easily within seconds. But if it was room temperature water, it needs to be left for a few hours. It could range anywhere between 3 to 5 hours, and it'll go away. So we're talking about anywhere between 30 to 40 degrees of water temperature. Now, you could argue that if it goes into cooler waters, what would happen? So it will disintegrate within a few weeks' time again without leaving any microplastics. But because the temperature of the water is cooler, it just takes a longer to disintegrate. And if it is sub-zero, it will freeze like anyone else. In terms of the packaging, it's not just sustainable, it's also extends the shelf life of fresh produce. And I'd like to highlight fresh produce here. We saw this happening with cheese. We took a piece of processed cheese, unbranded, and we left it on a countertop in Maharashtra, room temperature conditions, so high humidity, decent amount of heat, which is anywhere between 30 to 40 degrees for 2 months with no sort of controlled conditions. 2 months later, there was no fungus or mold forming on this piece of cheese. And then we experimented with this again with bananas, because bananas are more notorious for getting spoiled very quickly. So when you buy a bunch, you'll always find the sixth one or the 12th one not getting, it doesn't get eaten because it rots too fast before you get to it. What we did was we took PVC, we took LDP, we took BOPP, we took PET, and we put it in, we're talking pure polymers here, and we put it in that plastic. And then we also left one unwrapped, because there's also one school of thought is, why does fruit need packaging? A lot of products need packaging. It's just that what kind of packaging is that the right kind of packaging for it is something that needs to be thought. On day 10th, you can clearly see signs of slow ripening. We continued the sets with many different kinds of bunches from different places, and we always saw the same result. What we also noticed is that on the second or the third day, plastic starts ripening extremely fast, because the oxygen barrier is not as low as ours, and it is also trapping ethylene. So on the third day, you'll see a gas that is trapped inside plastic. These were a couple of sort of observations. What we're also doing is, because we're not food experts, so every food respires and transpires differently. We've just started our validation studies of different kinds of food. So, for example, leafy vegetables would require different kinds of transpiration. So we're working with them to figure out what is the right kind of packaging based on our formulations. So it will be a seaweed packaging, but we would basically change certain properties to best suited for these applications. Its applications are also interesting in the exports market because banana is one of the biggest export items in India, in the fruit category. Now, again, in this, these are sort of visuals of what you can do. So we just tested a few things. This is oil packaging that you're seeing in the video. Just regular vegetable cooking oil, breath mints, and then different kinds of grocery items or supermarket items that you'd see in the shelf. These are more visuals. So we just sort of started experimenting with different textures, different colors, different transparency, different kinds of products. So this is more an application in the fashion space, and a lot of people are like, "Oh, is there really an application?" And you're from the plastics industry, so I don't have to tell you, but the amount of plastic that's used in the fashion industry, in the warehousing, in the shipping space, it's tremendously high. Again, these are more shopping bag applications. So at the point of retail, these can be used. They can also be used by companies that are app-enabled grocery services, and we're talking to many such clients. And even in terms of transparency, you can see we can change a lot. In fact, what we are telling most of the major brands is don't make it look like plastic. Don't make it look extremely clear. Don't make it look like that, because a waste worker cannot differentiate between two similar looking plastics, and they do not understand 1 to 7. So try to make the product and the texture so different that the demarcation is very, very visible to someone who's untrained in the trade. Now, speaking of the polymers, do you have any questions? You haven't said a word.
We're just going through it, and we'll park our questions for the later.
All right. Okay. So, in terms of shelf life and degradation properties, Zero Circle is able to give you both for a lot of variety of items. Now, PLA, PHA, starch, seaweed. Again, starch may you can consider starch and starch blends and cellulose under this category. Here, the range that's taken in is because depending on the per kilogram rate and the grade we're talking about, the range will vary. Now, I have been extremely generous to the pricing that I've used for PHA. It goes much higher. It starts at much higher price. And so is the case with PLA. So the grades are like bin liner to a food grade, pharma grade kind of applications, and not just for packaging. So it's the polymer cost. Largely, the difference that you see between us and other seaweed players is India doesn't have any seaweed players, but there are really cool startups that are working in this space in Cambridge and internationally, more on the western side of the world. The difference that we see is they directly go to a company that will give them the extracts from seaweed. We don't buy the extracts from the middle person. We're directly working with the biomass, and we're extracting the material of interest. Now, it's not just skipping the stage, but we're also deriving a much, much higher yield. So our yield is anywhere 40 to 60 times higher. Sorry, my bad. It's 2 to 3 times higher than the yield that is derived by most players in the market, because the yield typically was taken into account for another industry, so they were extracting the polymer differently. When we work with this material, we try to derive it because there's more material of interest for us, which may not be of interest for other industries like food and textile. And these are the players. So, like I said, we work closely, with the grassroots level, all the growers, all the farmers, all the cultivators, all the contract manufacturers, and many, many people with many, many names. A large part of the produce comes, especially when you work at grassroots level, most of this work is done by women, because usually these are fishing families where the men are at the high seas. Women are doing a lot of chores with plastic and plastic nets. So they're very familiar with this water. So you're not really taking them elsewhere. That you're basically giving them a secondary livelihood. If it's not, if you're not considering it primary, at least it is secondary. In the fishing families, a lot of the fish has sort of gone deplete. So we are proposing that as a primary income as well. To a large part of people in Tamil Nadu and even in Maharashtra and some in Gujarat. And same goes for the location where this is growing. So seaweed grows naturally, but we don't take it out from natural environment. We only work with people who cultivate this. So we don't touch the balance of the ocean. We are only working with people who are going to cultivate this sustainably. And these are visuals from all over India. Now, this is a sort of like you can consider it a hatchery environment, which is right next to the shore. When the water is very very hot, especially during a heat wave, and something that we can relate to right at this moment. And so it can be a hatchery, which is basically when temperature or the conditions of the water are not ideal, it can go into that. However, it can also be cultivated in that. And these are simple FRP tanks. So this FRP composite tanks, which does not require high amount of energy. It's just basically a motor that is replicated the wave action. And again, no inputs are given here. They're just ropes that are put in. So if you were to look at this is the dried version of it, of the tank. And the water again is not fresh water; it's completely seawater, and the land that is used is right next to the shore, so it's not ever taking over anything usable, like a arable land or anything of material interest to humans. In terms of impact, I think you touched the right points. I'm just sort of covering them. The resin production stage of a polymer has the maximum impact. We are a company that's pre-production right now, so the processing numbers that I give you, we continue to look at them as the same as plastic, because the processing technologies will probably consume the same amount of or release the same amount of emissions. But what happens before it goes into the productions line is of consequence, because that's 60% of the emissions that are coming in the LCO of plastics. In that stage itself, we're seeing an 80% reduction, because seaweed is naturally grown, no energy is required again in the open sea. It is hand harvested and it is solar dried. And the extraction methods that we are using are low heat and very low exposure to materials and chemicals. So the exposure time is only a handful of hours, and we get the material finished, so it's not high energy intensive. And like I mentioned before, which is, if you were to convert plastics, zero circle will have no impact on water, food, and land. But bioplastics, if you were to look at it, if we were to use corn to make our bioplastics, it would require 50% of global supply of corn and 55% of fresh water consumed in India annually. That's my team. I have a larger team now, so this is my leading team right now. I don't come from the industry of plastics. I come from an industry which was not related to plastic at all. So I've worked in large tech companies. I started my career with Google, worked there for many years. And then slowly I transitioned out when I was looking for materials that were carbon efficient. And that's when I came across seaweed. I wasn't sure whether I was going to make plastics out of it, but that seemed like the right thing to do, because it's a natural source of carbon, which does not divert any resource. And for an application that's single use, it seems like the right fit. And when I was looking for seaweed and what to do with seaweed, I met Dr. Reddy. He's a veteran marine biologist who has years of experience. He has got over 50 years of experience working with seaweed cultivation side and downstream, which is basically applications and how do you make polymers or nutraceuticals and many, many products that can be derived out of it. Satej and Samir are scientists from NCL. Both of them have degrees, chemical engineering and chemistry background, very strong background. And they have years of experience working with new biomaterials. So not just a polymeric background, but also a background in the biopolymer space. And Nandeep has been working with us since the very beginning. We were incubated, accelerated by Nestle in 2020, and that's when even we were incorporated at the same time. So yeah, so he's continued to sort of help us in how we're building the team.
Thank you so
So
much. Yeah.
I have a couple of things that I probably want to add is since you're looking at a solution right now, we are currently scaling up our production. We are pre-production right now and we're heading towards our pilot trials. So June is when we're scheduled to run our pilots. And we should be done with multiple pilot scale-ups by July. And once the pilot scale-ups are done, we will start looking at setting up a demonstration site. So where our logic is to not sort of become the plastic manufacturer, but of course we want to set up a commercial site so it works as a demonstration facility for anyone who wants to work with us on licensing basis.
So licensing basis
And this
means you license the technology to get our own seaweed and make the whole thing, or you'll be giving, like you gave in your comparative chart, you'll be giving pellets or some sheets or something like that. So what is the deliverance that you will give to anybody who wants to associate with you? I mean, what is your product?
right. So right now, the process that's already in place is that we will give you the polymer and depending on the application, the way to make it. That was the initial plan. But right now, we are sort of changing gears to try to figure out if we can give you a formulated granule. So all you need to do really is to make it in your sort of manufacturing facility. The details of whether, what kind of lines it would be, those are things that we're currently saving it until we're 100% sure what that would look like for the world, because we're trying to see efficiency in every possible way. And the material quality that's changing depending on what kind of lines it's best suited for. So that's the experimental run that we're currently doing. But the idea is to not make people go after the seaweed or the seaweed extraction. You will get the materials from us. So quite simply, if you were to look at it, it would be something like the patty of the burger that we will be supplying to you. All you have to do is put it in an assembly line and manufacture it.
And that would be available earliest July. That's what you are saying, right?
No. So July is when we're running the pilots. The demonstration facility we will start setting up in Q4 of the calendar year. And by Q1, we will start our first commercial continuous runs in the demonstration facility. The demonstration facility is important because we could have done this directly through partnership, but that does not scale well. So we want to have control over the R&D and the continuous optimization of this at our facility. And it makes the job easier for other players who are in this space to understand the technology, how that's working. So we want to create a demo site.
And then this demo site would obviously, logically, it would be close to the seashore.
The point is, where exactly do we want to place ourselves? Because the seashore all across India is in many places. So, does it have to be close to us in Maharashtra or Gujarat? I mean, Gujarat is close enough for us. Or would it be closer to other places, coastal places again? Of course, North India does not make sense at this point.
Yeah, absolutely.
So yes, so it will be one of the wherever we are seeing maximum production of seaweed, our manufacturing would be closer to that. Now, the manufacturing and the extraction process is one, and the other one is the demo site for the production. Will they be combined or will they be working in different places? That's a detail that we need to figure.
Okay. So what you're saying is that initially you had planned for a licensing of technology, but now you're changing gears and you're going in for the patty. You're going to give the finished granules. Is that correct?
No, not necessarily. We are going to give you the granule, the equivalent of a granule that you get in a
Absolutely.
PP or a bio
Absolutely.
PP or
Yeah.
BOPP,
Yeah.
that sort of a granule.
Yeah.
Um, Licensing is still there, but earlier we were thinking of licensing right away. But we're right now saying that we want to set up a demonstration plant and then license through the demonstration facility. Otherwise, it's a little difficult to directly license
Okay.
without
So
having any control over trials and the
yeah,
scale
yeah.
ups.
So you'll be doing both. You'll be licensing technology as well as
A centralized facility that is doing
yeah,
the
yeah.
production, but
So
that is not going, that's not how we want to scale. Consider that as a non-competitive entity to anyone who wants to license it, because this is just to keep control over the R&D process.
yeah, obviously a licensing will be a very different format. I mean, it has to be on a non-compete situation, and also because you want to democratize the whole, learning that you have and commercially democratize it.
Correct.
Okay, so couple of questions on the thing. Raman, do you have any questions? You want to go first?
No, you can
Amandeep,
take. You can
uh,
take.
sorry, I actually have a call starting at 11:45.
How
Could
much
you
time
give
do we
me two
have?
minutes?
How much time
It's
do we
already
have?
started.
Give me,
Could
okay,
you give
then,
me 2 minutes? Let me just call them and
okay,
ask them for a
okay,
15-minute extension.
okay.
Yes, I'm back.
Yeah, thank you, Neha.
Yeah, sure.
Neha, now this film, could it also be used as a lining in various jars, etc.?
Because it's marine degradable, so if you're putting water in it, shampoo in it, it won't work.
So only oil-based formulations, not water-based
Yeah,
formulations.
non-polar. Yeah,
Okay. Once you are going to be ready with the granules,
yeah.
do you think they're going to be uh, good enough for making sheets and films, or they would also be good enough to make bottles and jars?
Only flexible films.
Only films. Okay. Now, when it's films, okay, so you'll just be giving the granules and films will have to be made by whosoever is making them.
Correct. And
what
we
is
will guide them. The process of licensing
yeah.
is to guide them through the process of how to make it.
Okay. Now, what is the carbon footprint of the zero circle granule? If you have some kind of an estimation of that.
Yeah, so that's what I said. The resin production process, if you compare it with the, let me just take you to that slide. So if you were to look at the LCA of PET, BOPP, largely, if you see, 60% of the emissions are coming from conversion, which is oil to pellet. Then from pellet to product, which is film, bottle, whatever it is. And then the last stage is end of life. In that calculation, 10% is associated to end of life because you're assuming it's getting recycled and that's not methane emissions, right? So in that, 60% of that is going towards resin production, right? We're not doing it at a commercial scale, but based on the scale-ups that we have seen, we've seen an 80% reduction in the first stage itself. So that's
Yeah, for example, Neha, now a plastic, depending on which plastic you're benchmarking to, could be anywhere between 1.5 kgs to 8 kgs of carbon dioxide per kg of the plastic produced. So, in
correct.
terms of an absolute number, I
Yeah.
mean, where do we stand in zero circle? Are we like 500 grams? Are we 200 grams to a kg? Or are we 1 kg to a kg of to kg of our granules? I mean, do we have an
we
estimated
have,
number?
yeah, we have a number. I think based on the number, we've basically put a figure of 80%. So I don't remember the exact
Okay, so
value.
maybe you can post the call, just update us on that.
Yeah, yeah.
Right.
But based on the the kilojoule value that we got, then further converted into CO2 emissions, we then looked at major publications that have published data for plastics and then converted that number to an 80% of that.
Now then it is important to know what is the exact plastic you took as a reference in PET, because there is a varying carbon footprint of every variant. So
Yeah, so these are I mean, see, we're looking at pure polymers published data, which is in major journals. So
no, what I'm saying is
what
that
happens is sometimes what you're looking at, how much, what stage, and you can get very, very specific in plastics in terms of even
no,
if
fair
it's
enough.
80
Fair enough. If
how
that
it
if that
could be.
estimated number is available, just share with us so that we'll be able to figure out what overall reductions it will create when put in different processes or different applications.
Sure.
Because that will be very strong.
I ask you, what is the per kilogram resin emissions attached to the polymers of interest to you?
No, I will send you an entire list, not an issue.
Okay.
But
Okay.
as you'd see that ABS is the biggest villain and ABS is the
Correct.
highest, but PLA falls somewhere higher than plastic, maybe 2.5 times of. But then the plastic bandwidth or the entire rainbow of plastic footprints will start anywhere from 1.5 and go as high as 8 kgs in terms of multi-material plastics. So anyhow, I will send you that, and then you can tell me which one you want to benchmark that 80% to, and we'll have some kind of a working figure. Because for us, when we will be calculating the entire, carbon emission reduction for an application, this would be a figure that will come handy as to what is the carbon footprint of the granule.
Absolutely.
Granule onwards in conversion and all, we'll add it up. That's not an issue.
So, Amandeep, I think the reason why we don't put out a number right now is any number that we put out right now is done at a non-commercial scale. And the numbers that you get at a commercial scale are very, can change distance.
Yeah, I agree. But I
This is
understand.
the reference point. Yeah.
Yeah, I understand that completely, that we are at a pre-production stage. But and that's why I just need an unofficial estimated figure from you, so that it will give us some kind of a handle to work with. That's it. I mean, we don't need any
Fair enough.
confirmations or anything on that, because that once you're running your pilots, you'll then have a much clearer vision on the number, so that we understand. At the end of the presentation, you said a spoonful of the ocean, and that lighted the sparkle in Raman's and my eyes, and maybe we can make spoons out of it. But then you said we
Yeah,
can make only
I,
films.
I
So, can we make spoons, or it's a creative line that you're using as
it started with the creative endeavor, but there is somebody in my team who's trying to figure that out as well.
okay, okay,
But that said, cutlery space is not the most exciting space for us, because
it is or it is not.
it's not. It's
Okay.
not.
देखो नेहा, चमचों के बिना कुछ नहीं होता इंडिया में, तो सोच लो.
The reason why it's not is when you're working with brands, right? So we're working with several global CPG brands, fashion brands, electronics, electricals. Basically, there's a huge sort of. We're working across domains.
Fair
One
enough.
thing
That's
that we've
fine.
noticed is that there's a clear winner and major search for a clear film packaging.
Absolutely,
When
there
you
is.
go
There is.
into
There
the
is.
millet spoon and the edible spoons and the edible cutlery space, it is so easily right now. It's overcrowded. Not saying that clear film packaging is not overcrowded, but finding a USP and a way to transition out of cheap, oil plastic is still higher than standing out in the crowd where you're fighting with a millet-based spoons and a crop-based plate. That is a very, very crowded space. So just a USP there is something that we've not been able to find. Like, why do we stand out there? Yes, we are probably coming from a more sustainable space. But for example, sugarcane bagasse is a difficult material to work with because, of course, waste is one of my favorites. So if I was not working with seaweeds, I would probably be working with either proteins or I'd be working somewhere differently in the waste space. But problem with bagasse is this is a peat, right? So when you're extracting that from an average crop waste, sugarcane is slightly difficult. The yield goes lower. All those things. At the same time, you're at the end of the day, you're only working with starch, right? Starch and the fiber and all of that. So all these things are interesting in the space of fiber-rich resources. Now, seaweed has fiber, but it doesn't have as much fiber than an like an areca nut or multiple other sources that you find in banana fibers. There's a lot of it's very cellulose rich. If we were to get in that space, we would require a mix of materials. Even though seaweed species, there are certain seaweed species that have decent amount of cellulose also in it. It's not going to be cost competitive. Well, that's at least my opinion at this stage. Until we don't have a ready product, I might sing a different tune once I have a new product in front of the world. But that's my take on it right now. Why that doesn't make sense? We may come out with a Me Too product, but it would not be the most original product there.
Got it. Got it. Raman, do you have any questions? Raman, you're on mute. Raman, we can't hear you.
So we haven't tried any plates or spoons or straws or glasses or cups or something like that from this.
No, I'm not saying that we haven't tried, but the composition, the formulation, the processing of it is going to be very different from what we are currently working with. The reason why seaweed packaging is a good solution for clear packaging is because it's different from a starch and a cellulose when we talk about biopolymers. This is the main component of it is a hydrogel, right? So the malleability of this material in a flexible film is much higher than anything that you find even in starch. Cellulose is more structured, is more crystalline compared to at least in the biopolymer unmodified world. Starch has a little bit of crystalline structure. This one is very, very amorphous. Sorry, I mean, I don't want to go down to the whole chemistry part of it.
No,
I'll sound
please
like
do.
my
I
college
mean,
girl.
it is very, very educative.
Yeah,
But anyway,
so the malleability of this material, so that's why when you hold the film, right, and you just shake it, like a cellophane film make a very loud noise. PLA film also make a little bit of noise, right? It cackles a little bit. Um, with our material, there's no, it's, I mean, I wouldn't say it's noiseless, but it's really does not make noise. So it goes down to the molecular structure of the material. So when we try to make a different kind of material which is more bhusa based, and that comes from waste, it requires a different composition and then different kind of binding ability to put it together, because you're trying to, of course, go without any kind of glues and polyurethanes and all those things that are attached on the coating surfaces. Even when you make something to make it stand and make it usable, you require coatings on top of it, right? Otherwise, your food will, if you put a curry inside a corn box or corn-based bowl, it will start giving in its mechanical strength very quickly, at least after a few hours. So it works, but it doesn't work. So to manage all the challenges, matlab, I can create a product in a lab, but will it stand the trial of the world is the big question. So that's why there is someone who's trying to work on it, but we're not trying to keep our focus more than 5% in the R&D sort of headspace.
Something like cups or straws, do you think they are workable in this?
They could be, like I said, they could be, just that we're not focused on building that, because really in the flexible space is so much going on that cutlery is not the biggest focus for us.
yeah, absolutely.
Unless if something happens accidentally and without any investment of time, it's also something that comes out of it. We probably do that. But making a cup and a cutlery is, we can make a cup out of it. Clearly, I mean, we've tested that it can, but it needs to be improved upon. It can't just be the way it looks. Like, you can't just compression mold something and just it's ready. It requires a lot of validation on it. Like, what is the use case of a cup? Structurally, I can make a cup out of a clay, but is it a good clay cup or a not a good clay cup? Requires a lot of modification on the surface. So the chemistry requires to be optimized.
And
I don't know if I'm able to get through to you on it.
100%. And what are your views on the other applications which you cite, like food, textile, shoe soles, medical and life devices? Do you think they are workable on that, or no, not right now in the current situation?
They are. So there is a polymer of interest which we are working with. Those are products that are not out. One is the part is the soft soles in the shoes. Um, so there is some sort of interesting development that's going on. But if it's not ready, I'll not talk about it. But yeah, that's one thing that we're looking at. Soft soles for shoes. We're trying to make it a bit performance driven than just shape driven, because shoes are very performance based polymers. So just getting this, the basic shape is not enough. And especially when you're going into a B2B market, it is a very, very performance driven product. People just don't want to wear, comfortable shoes. They also want to wear comfortable shoes.
And
So,
Neha, when did you start this? You started, you said, in 2020, or 2020 Nestle happened, you were doing it before that also?
incorporated, incubated, accelerated in July 2020.
Okay, okay, great.
Yeah, I started my search a little earlier. So I was working with scientists in ICT, which is in Institute of Chemical Technology. So they've done a lot of work. And Dr. Reddy, he's our mentor. He was the chief scientist at CSMCRI at one point before we retired. So CSMCRI is the Salt Marine Institute in Bhavnagar in Gujarat. So, we may have had, as a company, less than 2 years of experience, but the people who sort of came together to help us out, I think have years of experience. So
Experience, yeah.
that helps in acceleration.
Absolutely, absolutely. Okay. Do you see, just one thing that came to mind while we were discussing about that cup use case and all. Now, if you see a cup or maybe any other direction where there is a business case and there is further validation, research required on that, but you don't want to do it, would you be willing to hand it over or license it for us to take it forward and build that into a business case?
Um,
Think about it.
yeah, yeah. So the thing with collaborations is, and I'll be honest about it, we are currently working on a model which is R&D first and technology first, which means if we were to scale this, this will be completely, our revenues will be materials and royalty in licensing. So if we were to work with another player who's building the technology for it, would mean that the revenues would not make sense, especially in
No,
terms
no,
of
no.
scale.
In fact, it is something that is your waste. Please understand it that way. So I'm not saying that we would
It's not
collaborate.
a risk.
We not collaborate on the films that you are going ahead with. I'm saying glasses is today, which is being done worldwide, but you are not wanting to go in that direction. So it's like a waste for you. And that's not going to generate any revenue for you in the future as well, because you're not wanting to enter that space. But that is definitely doable. So if you were to give us a license, or because then you'll have a revenue in the upside coming to you as well, and all the costs hereafter on the validation, etc., under your guidance and your team supervision, we'll do it forward, and then uh, it could be additional revenue for you. There's not going to be We would not go into the film space at all. We would only be restricted to that space which you have rejected and you don't want to pursue. That's the only space we're talking about here.
Yeah, so I don't necessarily agree that this is a waste space for us, right? Like for example, if we are able to make a glass or any kind of dinnerware or serveware item, structure, properties, those can be fine-tuned once we enter that space. Um, the granule and the granule science around it requires changes in the chemistry. So for us to give you that granule that can be turned into a serveware product requires work on our side.
Fair enough. No, this is
So
just just
no, what I mean is that it's the chemistry itself that would require more work
more work on
than
your side. Okay. Okay.
just the granule
Okay.
turning into
No,
compression
this is
molding
just
and
this is just an offshoot that came up from the discussion. So I thought I'll mention it to you, and you can park it in your mind that for any other application or anything, because we have worked with a lot of scientists across, and we've also licensed technologies from them. We've worked with them in developing it, so it's absolutely fine. I just wanted to leave it with you. And now, so to summarize, the whole thing is that you're going to be ready with your material only in some time, and as of now, you are only testing, and there's not even a test material that you can give for us to try out on the applications you want to do. That will also be ready only later once your pilot is there.
Yeah, so the test materials that we're giving out with a letter of commitment in terms of financials. And those are the ones that are directly coming from brands with the commitment of sales that we have with them. Only then do we create samples for them to try out. Because honestly, like right now, in terms of sample requests, we have over 50 requests that have come from large brands. And we cannot entertain everybody as of this moment, because sample making would require like 50% of our R&D team to sit down and just make those
Sorry.
samples, right? So we're not stage ready in terms of giving samples out yet. However, once our pilots are completed, then it'll be much easier for us to hand over samples. So it's not like we can't give samples. We do give samples out, but it is at a very strategic level that we give out. for us to be able to create samples for anyone who'd be interested in our products. We'll be able to do that around July, I would say. So it's just a little bit of short wait, and then we should be able to give you samples.
Okay.
So Neha, what are the kind of filters you have while you choose between amongst these 50 plus part requests you have, so that if we could possibly see if there is a possibility of fitting in and we could kind of do it along with currently. So
Right.
that's where my question comes from.
Sure. So, I mean, there's no sort of discrimination here, honestly. There are a lot of people who have supported us, including, if I have to say, in an official capacity, Nestle. So the SKUs that we're talking about, I mean, they require right now easily 10,000 tons of packaging material on the flexible films. So there's a large sales requirement, and of course, they've guided us
Okay,
to
I found this on the web for easily 10,000 tons of pack.
I'm sorry, my Siri just went up. I'm so sorry about that. I was wondering who's talking.
The Siri is always the smartest.
Right. I lost my train of thought. Yeah. So these are very handful of people who have really committed to helping us, and they have no rights over the IP. From a product point of view, but just that they are very interested in sales, and they have a large order that they've committed from the very beginning. So just to contain the validation among a few players, we're only working with them, because just the R&D load becomes too much. So it's not so much around who do we work with, but these are like historically we've been working with them. So we continue to work with them. We do validation because, the number of criteria they give us, I don't think anyone else will give us any extra criteria to test.
Absolutely, and any large brand which will have to shift its packaging will need that much time. So probably Nestle has been wise enough to spend their time with you. They'll spend 2-3 years in validating everything and then only launch. And even a new brand which even comes in and commits, because all of them have hero products. So for them to
Correct.
shift their packaging, each one of them is going to need, even the next one is going to need, if not 3 years, maybe 1 year, because no one
Correct.
can risk their entire produce.
Absolutely.
Yeah.
So we start with smaller SKUs, and then we move to the bigger SKUs.
Okay.
So that's the rationale. That's
Yeah, got it,
but
got it.
once we're able to sort of dish out more samples from a more
Yeah.
easy machinery,
Perfect.
that we'll have reserved spots for samples.
Lovely.
We don't charge for our samples right now, so it's not from a distinction basis or anything. Just that it's
No,
ease
I
of.
would, I would be happier if you charged and gave, rather than you don't charge and you don't give at the moment.
If I were to give you an A4 size sample of a film, I mean, how much am I going to charge?
I am
right?
with
So
you.
it's really not going to help
Got
us.
it. We completely agree. Completely agree with you. So the bottom line is that for any kind of water-based requirement, it is good. For any kind of dry or oil-based requirement, it works fine.
Yeah. So anything polar is not. So water based anything would not work. Yeah.
Got it.
So
Raman?
yeah. But do you only have people in the food space, or do you also have people in non-food space?
See, we are, like I told you, pretty much like you. I mean, we changed focus of our consultancy service. The brands obviously needed it, and then we got out of the advertising space and we got into the sustainability consulting space. So we're also talking to airlines for their requirements, but our discussions are on both ends. One is products, and the other is, like I mentioned to you, on their pledges. That they've made that by 2030, 2040 they go to. So therefore we are while, because we were in these domains as our own brands, they are natural to us, but we are not like married to these and closed for other categories. So currently we are, like I told you, working with airlines, and in other spaces like apparel is a big one.
Correct.
And agri is another big area where we are
Agri
working.
is for sacks, or is that
No,
for
mulch mats and sustainable fertilizers and pesticides.
right.
And also we are developing a very interesting seed pod, which is a great savior for the seed as well as for the water, which is also based on similar technology. Even this film could have a large application there.
Yeah. So I think there's certain players who are in the agri space, the big guys. We just initiated a conversation with them, so they have all these products. I mean, any large player will have all these product lines. So we're also seeing if something that we can cater to in terms of direct application, not just
The
yeah.
only thing is that, uh, broadly speaking, a large brand will be a slow exercise. A smaller or a mid-sized brand will be faster application, and faster, maybe a couple of faster applications give a faster validation to the larger brand also to catalyze and expedite his process. That's what our experience so far has been.
Absolutely.